First, we're going to talk about an example of classical suppression. And in this case, we're going to imagine that we are researchers testing the hypothesis that a speeded quiz score will predict performance on a math test later on in the quarter or semester. And so let's say we collect that data and we decide to put another variable in the mix when we're planning this study. We believe that people's reading speed will impact their speeded quiz score, because people who are fast readers will just perform better if we have a speeded test of some kind. And so let's say we run the study on these students and we obtain the following zero order or bivariate correlations. So we have the DV, which is the math achievement score, and that is correlated with the speeded quiz score as we hypothesized it would be, 0.43, so there's a positive relationship. And we see for the reading speed, that was not correlated with the math achievement test score. So we see it's negative 0.06. So let's just assume for all intents and purposes that that is non-significant and could be 0 for all we know. So we'll just assume that is 0. And so obviously this math achievement test did not require any kind of speeded reading. It didn't require a lot of quick processing. It was maybe a slower test that the students were given plenty of time to complete. And then finally, we have the speeded quiz score correlating with the reading speed as we believed it would, 0.25. So there's a positive relationship there as we had thought. So those are the patterns among the variables, and it seems innocuous enough, but as we're going to see in the next segment, a pattern of relationships like this is really tough to interpret.